Hello everybody, welcome back to my channel. This is Alex Does LeetCode. My name is Alex and I'm going to be working with programming problems together with you. Alright, so today's problem is number 134 in the top interview 150 set. Name of this problem is gas station. I think one of the things I'm going to try to do starting from next time is to give my viewers the problem in advance so that you have a few days to try it out before we get together and you watch me do it together with you. This way you can actually try out your problem, and then it might make our time together a little bit more interactive. But I'm curious. I'm curious what people think. So leave a comment on the video. Your feedback is greatly appreciated as always. Now let's get started. Today's question is called gas station, and let's start by reading the question description as usual. There are n gas stations along a circular route, where the amount of gas at the ith station is gas I. So it's circular route, you get a list of gas. But because it's a circular route, somewhere along the way we'll realize that the last element of the list loops back to the first one. You have a car with an unlimited gas tank and it costs I of gas to travel from I station to the next, I plus 1, okay? You begin the journey with an empty tank at least one of these stations. Given two integer arrays, return the gas station's index. If you can, I don't get it. If you can travel around the circuit once in the clockwise direction, if there is a solution, it is guaranteed to be unique. I don't get it. Okay, let's look at an example. Okay, so gas 1, 2, 3, 4 costs 3, 4, 5, 1, 2. Starting at station 3, index 3, will fill up the gas with tank with 4 units of gas. Your tank equals to 0 plus 4 equals to 4. Okay. Travel to station 4. Your tank equals to 4 minus 1 plus 5 equals to 8. Travel station 0. Your tank equals 8 minus 2 plus 1 equals to 7. 7, I see. So at every station, you get more gas, and then you travel, you lose that amount of gas. Okay? And the idea is at no point is your gas tank allowed to go below 0. So obviously if the sum of cost is smaller than the sum of gas, then you'll never make it, right? Because you can only get this much total. If the sum of gas is smaller than the sum of cost, you'll never make it. Because this is you only get this much total gas, and it costs more than that to travel around the loop. Okay, so let's see. This one you can start here. Okay, here's a case where your car doesn't get around. So this would not work. This would also not work because you only get 3 gas from this station, but you need 4 gas to get to the next one. This one, you get 4 gas from this station, and you need 3 to travel to the next one. And at the next one, you get 2 gas from the station. So you have 1 left in your tank. You add 2, that's 3. You need 3, and then that covers it. But the gas after that fails. Okay, so first of all, as a meta commentary, I do not like this question because I think it's too much of a puzzle. It's too much of a logical / mathematical puzzle, and not so much of a programming exercise. But we will solve this puzzle, okay? We will solve this puzzle together. I think I will be a little bit more selective about my questions so that we avoid questions like these. I think the thing about this question is that once you figure out what you're supposed to do, writing the program is easy. It's really, really easy. Once you figure out the math, right? And of course, this is a big talk from a guy who has not figured out the math yet. And there's definitely a risk that I would have to eat my words. But let's see how it goes. So, here's my first instinct, okay? Here's my first instinct. Look at these two arrays. Essentially, what's happening is that assuming you're at at any particular gas station, your tank is 0 or more, the amount of gas that you end up with at station I plus 1 is gas minus cost. So you don't actually need 2 arrays. You only need 1 array. And the 1 array is gas minus cost. You take each item in gas and you subtract from each item in cost. Now, there's definitely a Pythonic way to do this. I'm going to figure out what it is. Let's call this diff. Okay? So your diff, for instance, in the first example will be something like this. Minus 2. Gas minus cost. 1 minus 3 is minus 2. Minus 2. So 2 minus 4. Minus 2. 3 minus 5. Okay. So this is 4 minus 1 is 3. And then 5 minus 2 is 3. So you see, right away the following property. If you start anywhere which is you start at a negative number, you're gonna fail right away. Okay? So the idea is you have to pick a number. Pick an index where you can travel around essentially. This allows you to do that. So 3, 3, minus 2, minus 2, minus 1. Okay, so my first instinct actually is to pick the highest number. The highest number in this case works. 3 is the highest number. 3, 3, 2, 2. But the highest number does not always work. For instance, in this case, the highest number does not work if your highest streak, the sequence of highest numbers is not very long. Then the highest number is not gonna work. My second instinct is to find the largest streak of of positive numbers. So it says here, the solution is guaranteed to be unique, which tells me, I'm not sure what it tells me. So this becomes a bit more interesting if you get something like this. Then the answer is start from here. But something like this will require you to start from... Oh, no, I don't think this is a solution. Oh, you still start from here. Interesting. Okay, so my next instinct is to create a cumulative sum, right? The diff. The cumulative sum so the cumulative sum basically adds them up in sequence. And it looks something like this. Minus 2, minus 4, minus 6. Minus 3. So let's do this one. Minus 4, 0. Ah, okay. This doesn't help. This again does not help. Because this changes if, for instance, I wrap this around. So this is what I meant when I said the puzzle requires a lot of... This is basically a puzzle, right? The idea here is... Yeah, the idea here is it basically becomes a puzzle. What if I wrap it around this way? It becomes a puzzle where you're trying to sort of apply some lateral thinking to figure out what's going on. 1, 0, 4, minus 2, minus 4. Interesting. So I've noticed that the solution is always one after the lowest one. That's not true. So this one is actually not one after the lowest one. Okay, I've tried a few things. I tried to look for patterns. I'm pretty sure this is definitely the right step. The first step is to find the diff, which is gas minus cost. And then based on this, or whatever one of these diffs, I need to find a way to rotate this diff, yeah. So I need to find a way to rotate this so that the cumulative sum at any point is greater than is 0 or more. If you can rotate this, array, this list, such that the cumulative sum is at any point is 0 or more, then you win. Okay, so let me think about it in a different way. So let's say there's one station. So ignore the gas and cost. Just focus on diff. right? Let's say there's one station, and it is -2, so it needs to be 0. It needs to be 0 in order for this to work. Okay? What if there are two gas stations? Then it doesn't have to be 0. It doesn't have to be 0. Then what you do is you start at but they have to add up to more than 0. Okay, so you have to start here in order to succeed. Now, if I add a third gas station, then either you have to start here. Oh, so this is assuming there's a solution for... this is assuming there is a solution. Well, I'm stumped. You know what? I don't like this question. I am going to switch to a different question. Because I really don't like it. Let's pick a different one. Let's pick this one. Roman to numeral. Roman to integer. Just because it's easy and we've taken up a bunch of time already. So next time what I'll do is I will figure out what question to tackle beforehand, so I'm not so random about what kinds of questions we do together. And this gives us two things. One, it allows you time to figure out what you want to do, to try and attempt the question on your own. And two, it avoids this problem of having puzzle questions. I don't like puzzle questions. Alright, cool. Says here Roman to integer. Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, M. Okay. 2 is written as II. Just add them together, which is fine. Okay. Largest to smallest. Left to right. However, the numeral for 4 is not for III. Instead, the number 4 is written as IV. Because the 1 before it and the 1 is before the 5 is subtracted, making 4. Same principle applies to number 9, which is IX. Okay. I can be placed before V and X to make it 4 and 9. X can be placed before L and C to make it 40 and 90. Okay. So can I do IC to make it 99? XCIX. So the answer is no. So 99 is XC9X because it's two parts: XC, which is 90, and IX, which is 9. You can't just take C, which is 100, century, cent, and you subtract I from it to get 99. Okay, so you can only subtract. You can only subtract 50, 100. Gotcha. And you cannot say LC, right? You can't say LC. Okay. And then C can be placed between D and M to make 400 and 900. Okay, so this is not too hard. This is actually pretty straightforward. It sounds a little complicated. So, for instance, let's take one of these. Okay, this is a little bit this may look intimidating. So the trick here is separate this into a bunch of stuff. Okay, and the way you want to do it is, first you want to separate all the M's. You want to separate like at the macro level. All the M's, all the D's, all the C's, all the L's, right? It's not so straightforward because the m's can be modified by c. So this I will separate into here, here, and here. 3 things first. Okay? And for each of these, I will separate them into MCM, M, comma, CM, X, C, and then IV. So IV and CM are single units. So that's how I think about it. I have a string, I'm going to separate this into, I'm going to sort of tokenize it, right? I want to split it up. And so the way I'm going to do this, that's the goal. So I want to split it up. So at any one point, so there are 2 levels of splitting. At the top level, we want to know if we are in M, D, C, where are we, right? Are we doing like MMM? Or are we doing like M? Yeah, MMMD. So D means that it's the next one. Okay? Yeah, actually we don't even need 2 levels of splitting. Now come think of it. We just need to recognize these like modified characters. So you see an M, we go from left to right. If we see an M, we add 1000. You see a D, that's 500, blah 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 blah. Except when we see a C, an X, or an I, we have to check the next one. We have to check whether this is an I, whether it's like this, or it's like this. Okay? So this is not super hard. Total, let's initialize it to 0. We are going to go down the array for let's call it X because there's no X in S. If X so you have a giant if statement if X X. Is there a switch in Python? Oh, I like switch better. Because switch is a little bit more aha, yes. So I like switch better. A match statement better because it's a little bit more structured than having a bunch of nested ifs. Okay, I'll explain why later. Equals to M, then do blah, elif X equals to blah, D, then do blah. So this is less good because it's not like if I read it, let's say this is really long, right? This is like 1000, it's like super long. As I'm reading the first 2, I notice that the condition is to match on X. But I don't know if every single one of these is of the form X equals to something. I don't know that. Maybe somewhere down the road it says if Y is greater than 16 or 125 or whatever. Right? That trips me up. Both as a reader and as a writer because sometimes you screw up. So, as a general rule, I need to increase my Python level. What the heck? Ah, dude! Come back. I need to go to Python 3 in order to match. I don't know whether I have match. Let's see if I have match. see if I can run this. Indented block after match statement. Okay, so it recognizes match as something special. Okay, cool. So match X, if X is M, X is D. You know what, let's just use the ordering given to me over there. If X is I, V, X, damn it. L, C, D, M. Okay. So for most of these, what I'm going to do is, I think I can do this. X total plus equals 1000. I think I can do this. 1, 5, 10, 50, 100, 500. Okay, cool. And then return total. Okay, so the part that needs to be checked is I, X, and C, right? So I can't do this yet. If numerate as I have to skip. Oh, this is annoying. Can I skip 2? Oh no, this is not what I'm looking for. Skip 2 or more iterations in a for loop. In numbers iter. Oh, okay, I have to do something like this. I have to use an iterator. I can enumerate. Okay, you know what? Let's do it the easy way. While index is smaller than length of S, I'm going to do this the easy way. X equals to S index. Okay, so I'm going to use a while loop to simulate a for loop. And reason why I want to do that is so that I can control the loop and make it skip twice. I can actually do that Pythonically using an iterator, but I don't want to use an iterator right now. So let's see. So if S idx plus 1, so the next one equals to V, then I know total plus equals to 4. idx plus equals to 1. Total equals to 10, idx plus equals to 1. Okay? Oh, sorry, 9. Alright, so I do this for x. So same thing here. L and C. L will be 40 and C is 90. XC, XL. And then C oh, one more case. Else total plus equals to 1. Total plus equals 10. Then this is part of the standalone X or I or whatever. Okay. Alright. So these things look really intimidating, but they don't have to be. They shouldn't, right? They shouldn't. After a while, you get used to it. After a while, you get used to it. So, beginners don't do this because they don't care enough. Experts understand that this is just part of life and they're happy to leave it the way it is. But somewhere in the middle, somewhere you might find intermediate programmers that say, hey, this for loop, this if statement is a huge giant snake. Let's simplify it. And you can. In fact, you can simplify all of this. You can see a pattern here, right? The pattern is if you, this symbol is like, before has a greater symbol after it. So this I is worth 1, but it's, just before 5 or just before 10. Then it does something a little bit different. It subtracts 1 instead. So that there is a pattern that you can exploit. And so intermediate programmers might say, hey, let's exploit that pattern. Let's create a hierarchy of symbols. And then check if my symbol is just before a symbol that is higher than me in the hierarchy, right? So you can actually do that. And that would be something that you should absolutely do if you're dealing with 100 symbols or even 20 symbols. For this, there are only 7 symbols. So I would not recommend you do that. I would recommend you just write it out. Write out the sort of dumb way, the old-fashioned way, and call it a day. It's fine. It really is. You might make mistakes. So, I might say this, or I might say 40 instead of 400. You might make mistakes. So you have to double check your work. But if you do it the other way, you will make mistakes. Well, actually, the chance of you making a mistake is lower, because in the other way it's more complicated. If you make a mistake, you'll find out almost right away. However, the person reading your code would be very unhappy. This code is long, but it's readable because it's obvious. Okay? This code is long but readable. However, in the case when there are a lot of symbols, when you find yourself doing something like this, right? Like this, there's a lot of symbols. There are like pages and pages of symbols. Then yes, then it's time to build something smarter. Time to use the principle, do not repeat yourself. There's a principle that I actually like a lot. There's this principle called do not repeat yourself. Don't repeat yourself. Okay? Which, if applied, will essentially try to find a smarter way to do what I just did instead of copying things that are modified. There's another principle that I personally like a lot. which I think you'll like more and more as you get more advanced and you start reading a lot more code than you write. It's called write everything twice. A small number of repetitions like this is perfectly fine. If there are only 2 cases, then this is not something you refactor to a more congruous structure. 3 cases, still no. 4 cases, okay, now you're pushing it, right? 5 cases, maybe it's time to refactor. It's 10 cases, then yes, absolutely refactor. So you have to sort of understand a little bit what your code is like, and you have to think about how you want to do this. Okay? So for instance, a very simple restructuring might say def check before. And then I can copy this piece of code here, right? And I do like, this is, like yeah, I won't change it. Essentially, it says you will say like check before I, and then you do like you give it like a hierarchy of symbols, bunch of symbols, which would be something like I V X L C blah 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 blah, and then if you say if as idx plus 1 equals symbols something, yeah, so that's one way of refactoring it to make it less repetitive. But in this case, I want it to be more repetitive. I think this level of repetition is fine. Making it less repetitive has a cost. Excuse me. It increases complexity, especially to the reader, and I don't like that. This is still okay. So notice how it's so easy to make errors, right? I'm just copy and pasting. If I forget to modify this from 90 to 900, boom, I have a bug right here. Okay, so let's run this. Make sure this is working. Pretty sure it works. Oh, run invalid syntax. Line 8. What? Am I doing this wrong? Case. Gotcha. You can't just write it this way. I don't even know if this structure is valid, but we'll find out. String index out of range. Wait, while IDX is smaller. Oh, if IDX is smaller, I see. So you're sort of at the end. So the string index out range happens somewhere here. This IDX plus 1. See? So when you see a string index, this index out range thing, just look at all the places where you check the index, right? This is fine because IDX is guaranteed to be smaller than length of S. So this will never go out of range. And it starts from 0, so it'll never be out of range. But this I plus 1, this is the part that's tripping us up. So you have to check that IDX is smaller than length of S minus 1. N. Okay, let's run it. Think this should work. Case 1, 2, 3 works. Let's run it. You know what? Let's start the study plan to see what the study plan says. I don't know what the study plan is. Okay, cool. We submit this and then we're done. We're done for today. But before we go, let's do a thing. Let's pick out a problem to solve the next time around. Next, let's pick out a problem to solve next time around. And I see one likely candidate, which is the one right here. Integer to Roman. This is interesting. Okay, this is very interesting. And it's medium. I don't think it's that much harder than the one we did before. But it will require a little bit more engineering. And I like this because it's not a puzzle. It's not a math puzzle. Okay, cool. So let's solve this for next time. Integer to Roman. I'm going to post this on my channel so that people know. You know what? Let's do it right away. Your videos. Should I put it in my description? Is that how I do it? Oh my god. Dashboard. Content. You know what? I really should not show this to people. I really should keep this more private. Man. I don't think about these things. Okay, you know what? Let me think about it. I am going to retool my channel layout a little bit. Make it a little bit more professional. Unfortunately, many of my videos have things in it that I don't want to show people. But you know what? Let's just see what happens. Maybe those are famous last words. Okay, either way, here's me signing out. Thank you very much for your time. See you next time.